Power to the truth. This is Margo. This is Friday, March the 8th, 2019, and it's 4:17 p.m. Pacific Time, United States of America. So we're going to be talking a little bit more about methane today. I have a research paper that I'm going to present, and it's about methane on the Yamal Peninsula, which is right up here to the east of this Kara Sea, and I think you're going to find it quite interesting. It's a whole study that they did about methane deposits in the ground and the sediment on the Yamal Peninsula and a couple of other places up here in Russia. So we do have some new methane data on cams today. Yesterday we showed new data from Wednesday, February 27th, and so they put up one new day's worth of data. So they took down Wednesday the 27th, and now the new data that we have is for one day. It's for last Thursday the 28th, so over a week ago. So I've chosen the Arctic view and surface level. I have the movie loaded up, but this is where we left off at the end of Wednesday, and we were seeing some dark release coming up through the Kara Sea again, and then this release from the Chukchi Sea that was moving across and around in this North Pole region. So let's run this movie and you can see what's going on. So we see this big release that built, and now in the forecast period it built and is releasing in the Kara Sea, and it's actually from that region where the study was from. So I think you're going to find this this paper quite revealing, and it's going to back up what we're seeing with the methane releases up here, and it's going to continue. It's not going to stop because of what's happening. So we'll run this through again. Here it is towards Sunday and Monday in the forecast period, which was earlier this week. So we're going to stop it right there at the end of Thursday. And I also have pulled up the North Pole view so that we can see the whole northern hemisphere. And so let's run this movie and see more methane release around the northern hemisphere. We can see a lot coming out of China as usual, India as usual, and we're seeing a lot coming out of the United States. And look at this wave that just moves across at the end of the forecast period. Across the United States. I find it quite fascinating. And look at this heavy release here last Saturday. Here comes the wave. Look how it's moving. I'm going to pause it right here. That's right at the end of the forecast period, which was Monday. And so this wave just came all the way down, and this is surface level, so it was releasing all the way across the just going all the way across the bottom part of the United States and releasing. And I'm thinking that's when we had those tornadoes that went across the south. So I'm wondering if that was related. I don't know. It could have been. It could have been related, most definitely. So I'm I'm going to make that into our background. And we might be coming back to cams as a reference while I go through this article, but we can do that. So the next thing we're going to cover is this research paper. This was published in Geosciences last year. It's an article and it's called Methane Content in Ground Ice and Sediments of the Kara Sea Coast. And so here are the authors, and they were from the Moscow State University, and Russian Academy of Sciences, and Department of Geography for Washington, D.C., George Washington University. So it was published on November 23rd of 2018, and I'd like to give a shout out to Marcia Noren, who sent me this article. She was the one that found it and did the research and pointed it out, and it's quite eye-opening. So thank you, Marcia, for bringing this to our attention and doing the research. And this is what I want, because this is a global classroom and we're all here to learn. I'm not going to read the whole article because it's got a whole bunch of scientific stuff in there that we probably can't understand, but for those of you with a scientific mind and know all the formulas and stuff, you're certainly welcome to read through it, because I will leave the link below. But we'll read the abstract and the conclusion, and we'll get the gist of it, and we can look at the charts too. Abstract. Permafrost degradation of coastal and marine sediments of the Arctic seas can result in large amounts of methane emitted to the atmosphere. And we've been seeing that. And this is exactly what Natalia Shakova was talking about too. The quantitative assessment of such emissions requires data on variability of methane content in various types of permafrost strata. To evaluate the methane concentrations in sediments and ground ice of the Kara Sea coast, samples were collected at a series of coastal exposures. Methane concentrations were determined for more than 400 samples taken from frozen sediments, ground ice, and active layer. In frozen sediments, methane concentrations were lowest in sands and highest in marine clays. In ground ice, the highest concentrations above 500 parts per million and higher were found in massive tabular ground ice, with much lower methane concentrations in ground ice wedges. Now, just to give you some context here, we've been looking in parts per billion over here on cams, okay? So this scale is parts per billion, and so when we see like this dark brown can be anywhere between 2140 to 10,000 parts per billion. So when they're saying 500 parts per million, if you want to do a conversion, 500, that converts to 500,000 parts per billion. You get that? So 500,000, so that's like 50 times more than the highest reading on surface level. 500, that's up to, they found, so let's look at this. So what they found was the highest, The highest in methane clays. In ground ice, the highest concentrations above 500 parts per million and higher were found in massive tabular ground ice. So there you go. So the methane, there's like exponential. The methane that's stored in the ice in the ground it's unbelievable. I mean, this is going to blow your mind. It's unbelievable. The mean isotopic composition of methane is minus 68.6% in permafrost and minus 63.6% in the active layer, indicative of microbial genesis. The isotopic compositions of the active layer is enriched relative to permafrost due to microbial oxidation and become more depleted with depth. So that means it's more active towards the surface where the microbes can grow, where they've got the oxygen and can grow and do their breaking down and everything. Ice-rich sediments in Kara Sea coast, especially those with massive tabular ground ice, hold large amounts of methane, making them potential sources of methane emissions under projected warming temperatures and increasing rates of coastal erosion. So we're talking about, here we have on Google Earth, here's the Kara Sea. So we're talking about these coastlines. This is the Yamal Peninsula, and this is where they did their investigation. But we're talking the sea coast. I mean, I'm thinking all the way around. But it just depends on the kind of ground that the ice is in. If it's sandy, it's not going to be so bad. But if it's clay, then the ice is in the clay, then you're going to have very high stores of methane in that ice, frozen in the air bubbles. Introduction. Methane emissions from permafrost are one of the topics requiring immediate attention due to potential significant implications to the Arctic and global climate system. Some studies speculated that methane emissions due to subsea permafrost degradation can significantly affect the climate. Now that's the work of Natalia Shikova, while others suggest that even under the most extreme scenarios, methane release from subsea permafrost will have little to no effect on the state of the climate. Due to the divergent views, methane content in permafrost regions requires further investigation, as general lack of field data adds to uncertainty of timing and magnitude of methane emissions for both terrestrial and subsea permafrost regions. The major sources of methane from terrestrial permafrost are bogs and wetlands and degrading permafrost, with a considerably smaller contribution from the geologic sources. The methane emissions from permafrost on a shelf of the East Siberian Arctic seas are expected due to high organic content of the sediments. So that's that East Siberia ice shelf that we've been talking about over here. And on cams over here, that's what they're talking about, that East Siberia ice shelf. However, not all permafrost-affected soils are characterized by high methane content. Sediments of marine and lacustrine genesis of western Siberia, which were freezing epigenetically after sedimentation ceased, are generally characterized by high methane concentrations, while the ice complex, Yodoma sediments, characteristic of Russian northeast, which were freezing syngenetically or simultaneously with sedimentation are generally characterized by low methane concentrations. The distribution of methane with depth of permafrost depends on the presence of buried organic layers and soil texture. For example, clayey soils are known to have higher methane contents relative to sandy soils. The complexity of methane distribution in permafrost increases in areas where permafrost caps gas-bearing sediments formed through the process of diagenesis and catagenesis, resulting in further transformation of organic material under pressure and temperature. Field studies of methane concentrations in permafrost are rare due to logistical constraints associated with obtaining methane from frozen samples for such analysis. Investigations conducted by the Canadian Geologic Survey in the Mackenzie Delta found methane concentrations above 5 ml to kg in frozen sands at 18 to 345 meters depth. Several studies reported generally higher than atmospheric methane content in the ground ice wedges in Canadian Arctic and eastern Siberia. The analysis of texture ice extracted from the Pechora seafloor, 43 to 45 meters water depth near Kara Gate Strait, showed that methane content of trapped gas was above 4,390 parts per million. So if we can convert 4,390 parts per million to parts per billion, it's 4,390,000 parts per billion. I mean, I can't even comprehend that. That just blows my mind. So they're saying there's a huge amount of methane there. Over 4 million, almost 4.5 million parts per billion. Analysis of the gas composition of the massive tabular ground ice, or MTGI, was conducted in Canadian Arctic and Western Yamal. These studies report high concentrations of methane trapped in the air bubbles within the ice. In some cases, the methane content in MTGI samples was 1 to 2 orders of magnitude higher than in the atmospheric air. These high concentrations were attributed to microbial methanogenesis occurring under conditions of temperatures below freezing point. Several studies found that methane production in the active layer can be substantial, but only in labile organic material if labile organic material is abundant in the soil. The isotopic composition of methane in ground ice and frozen ground is indicative of the genesis, with the majority of studies showing biogenic genesis of the gas. So, anyway, it goes on and on. Okay. Additional studies of methane content in origin and permafrost are needed in order to evaluate the role of permafrost carbon feedback. This paper presents data on methane content and distribution in permafrost, active layer, and ground ice collected in coastal exposures of Kara Sea region. The major goal of this research was to evaluate variability of methane concentrations in various types of coastal sediments and landscapes of coastal zone. Particular attention was given to methane content and genesis of the massive tabular ground ice deposits which are common to this region. And then they go into the whole study area. This is like here's the Kara Sea, here's the Yama Peninsula, here are the 3 places that they took their samples, and they go into how they did it and all their testing and all that stuff, materials and methods, and results and discussion. Methane is the most abundant hydrocarbon gas found in the ground ice. It has an order of magnitude higher concentrations than any other hydrocarbon detected. The concentration of methane varies substantially depending on the age and genesis of the strata, type of ground ice, and cryogenic conditions. And so on. Conclusions. Methane concentration in ground ice and quaternary sediments of the Kara Sea region have a substantial variability. High methane concentrations are found in marine clays with the presence of MTGI, where methane concentrations are the highest. The sands which freeze simultaneously with sedimentation have lower methane concentrations. Ground ice wedges are characterized by an order of magnitude less methane concentrations than MTGI, but several times higher than reported for ice of glacial origin. Results of the study further support evidence of higher methane concentration in epigenetic relative to syngenetic permafrost previously reported for the eastern Siberia regions. High concentrations of methane in permafrost is attributed to migration and conservation of methane in ice bubbles under advancing freezing fronts, which is supported by the isotopic content of methane. The microbial origin of methane confirms that methane in permafrost is not related to seepage or migration of mantle methane through permafrost. It also confirms the non-atmospheric origin of massive tabular ground ice bodies widely present in the study area. The highest mean methane concentrations were found in wet polygonal tundra, 8,560 parts per million. So that's 8,516 parts per billion. You got that? Bogs, which are 4,507 parts per million, which would be 4,507 parts per billion, and bottoms of the water tracts of 3,681 parts per million, which would equate to 3,681,000 parts per billion. These types of landscapes, which together compose almost 40% of typical landscapes of western Yamal, can be a significant source of methane emissions to the atmosphere. The landscape types that are characterized by good drainage, primarily sands and blowouts, have little methane available. Northwest Siberia has experienced one of the highest rates of climate change, with increasing air temperatures, increased thaw depth, and permafrost warming, with these trends likely to continue in the future. The upper part of the coast in the region is composed by ice-rich marine clays characterized by high methane content. Permafrost degradation due to climate change will be exacerbated along the coast, where declining sea ice is likely to result in accelerated rates of coastal erosion, especially in areas with presence of MTGI, further releasing the methane, which is not yet accounted for in the models. So these aren't accounted for in the models that they're talking about methane release. So this is adding more. So we're so much more screwed than we thought we were. The estimates of methane and various types of permafrost and ground ice are therefore an important contribution in regional assessments of the methane emissions from permafrost as valid to the Earth system models. The stable isotope analysis of methane is an indicator of ground ice formation, can be a useful tool in the paleo reconstructions, particularly in the areas where the glacial versus marine origins of massive ground ice are still debated. And then here's all the acknowledgments and references. Let's see how many references they have. A lot. 54 references. So this will give you some more things to think about just when you thought it couldn't get worse. So this is why we're seeing so much methane being released here in the wintertime even. And this is an area where the sea ice is not coming back. And we've seen that on NASA Worldview. You know, when the sun started coming up, we saw very little sea ice over here. It's very thin, and it's melting quickly. And I'm sure they're probably trying to dump a whole bunch of crap there, trying to make it stay cold to keep the methane in. That's probably only making it worse. So there you go. So I will leave the link below for that article and for your conversion chart if you need it. Parts per million. Put that in the show notes. Just in case you might have a brain fart like I do sometimes. So there you go. Especially when you're thinking about this stuff, it's easy for your thought processes to just shut down. It's like, did they really say that? It's like, oh my God, did they really say that? Is it really 8 billion, you know, parts per million? Parts per billion? 8 billion parts per billion. 8 billion and something parts per billion. It's like, I can't even think that. I have a hard enough time just thinking the regular stuff. So, anyway. So now we're going to go to earthquakes. Let me get a drink of my tea. I think I shorted out my neurons reading that and trying to think about it. We've got a lot of activity. We're getting more activity in the U.S. and larger earthquakes over in the U.S. too. And we had a big one. The biggest one today was a 6.0 that came in near Santa Monica, Philippines at 7:06 this morning. So we got USGS pulled up here, and we're showing 214 earthquakes from all magnitudes worldwide in the last 24 hours. And of those, 42 are 2.5 magnitude and higher. So let's see what we got to get to first. I think we're okay. Yeah, I think we're okay. I'm going to go ahead and start with what's going on. Well, let's get this one over here in the Red Sea. Remember, we saw two over here right on that red line in the same place a couple of days ago. We've got another one. It was a 4.6, and that came in at 9:20 this morning, right there in the middle of the Red Sea, in between Africa and Saudi Arabia. Then let's remember, we had some big ones down here in the Kermadec Islands in the last few days, and we've had two more at L'Espérance, or near L'Espérance. We had a 5.0 at 3:57 this morning, and another 5.0 at 4:51 this morning. Then over here on Papua New Guinea, we had a 5.2 near Abipura. This came in last night at 9:32 p.m. and was on land, and that could have caused damage if that was in a populated area, so I don't know what happened with that. Then here's a 4.5 near Sangyeong, Indonesia at 1:38 this morning. And then here's the 6.0 near Santa Monica, Philippines at 7:06 this morning. It was 54 kilometers deep, and it was in the ocean, so more than likely it didn't cause any damage. There was no tsunami warning created from that, but we can see it's right on that red line. Then here's one to the south of Taiwan, a 5.4 near Taitung City, Taiwan, that happened yesterday at 6:32 p.m. Then this one just came in, 4.2 near Harare, Japan at 4:08 p.m. And then moving on around, here's one on the Kamchatka Peninsula in Russia, 4.4 near Yelizovo, Russia at 6:47 last night, 107 kilometers deep. South America is quiet. They had a whole bunch of activity yesterday. Then off the coast of Mexico, we have two here. We have a 4.3 that happened yesterday at 6:07 p.m. near La Gomera. That was in the ocean. And then a 4.1 that happened at 3:07 this morning. It was 37 kilometers deep. And it looks like it was just off the coast. So I don't know if they felt that or not. And now I'm going to move over to all magnitudes for the Dominican Republic. We've got 15 listed here today. I'll just click them off and call them off. A 3.3, 3.1, 2.2, 2.7, 3.4, 3.4, 1.6, 3.0, 2.8, 2.4, 2.9, 1.6, 1.4, 2.6, and 2.7. Some of those were kind of deep. A couple of them were like over 100 kilometers deep. But that's not big enough to cause damage, really. Now Hawaii. We're only showing two on Hawaii. 2.2 near Lalani Estates at 11:58 this morning, and a 2.0. It looks like this is in Kilauea. Yeah, right in the crater. This happened at 12:42 this afternoon. Now let's go up to the Alaska region. We've got 56 here of all magnitudes for Alaska today. We're going to start with these two down here in the Aleutian Islands. We're starting with a 4.2 near Kiska Volcano, Alaska. This one happened at 8:20 this morning, 35 kilometers deep. And a 3.7 just on the other side of the island chain near Sitkin Island, Little Sitkin Island, Alaska at 8:20 this morning, 26 kilometers deep. Coming on around, here's a pair, 2.8 near Nikolsky at 1:14 this morning, and a 2.7 near Nikolsky at 4:21 this morning. Next is 2.5 near Cold Bay at 3:14 this afternoon. This one just came in, 3.6 near Kodiak at 4:09 p.m. today. And down here, 2.2 near Kodiak, 2.2 near Kodiak, 2.1 near Anchor Point, 2.1 near Old Iliamna, 2.0 near Anchor Point, 2.6 near Redoubt Volcano, and here's a 1.6 near Redoubt Volcano. So we're seeing more in the 2s range, and we've got some more higher ones. Here's a 3.6 near Willow. Here's the Anchorage area. Here's a cluster up here. Let's hop over to 2.5 magnitude and higher. We saw that 3.6. Here was 2.5 near Bear Creek. Then we've got more activity up here at Kobuk. 2.5 magnitude and higher. Well, we've got a 3.1, 0 kilometers depth. That happened last night at 7:45 p.m. 3.3 last night at 11:21 p.m. 0 kilometers depth. A 2.8 at 10:32 this morning at 0.9 kilometers depth. And 3.0 at 10:58 this morning at 0 kilometers depth. Now if we go to all magnitudes there, let's see what we've got. Oh, that's it. That's what we've got up at Kobuk. Remember, we've had some clusters up there. Here's one that just came in, a 2.1 near Badger. It's a 2.6 near Onoktivuk Pass. It came in yesterday at 5:48 in the afternoon. And 1.6 near Koktovik yesterday at 10:53 at 0 kilometers depth. So when they're right at the surface, I don't know exactly what to think. There's movement. I mean, there's movement making it happen right at the surface. So I don't know if the magma is moving up in the mountain and making it happen right at the surface. I know when we see a negative depth, it means that the magma's moved up into the mountain. Like, a lot of these are volcanoes. Here's a 2.0 at Haines, 0 kilometers depth. And, you know, like I showed a couple of days ago, I mean, there's a whole slew of volcanoes through Alaska and down this coastline, down all the way down. Okay. Uh-oh. Don't let me lose my voice. Okay, here's one down in Baja, Mexico, a 2.8. It happened at 8:21 this morning. Now in the lower 48, we've got a little cluster of 3 in this New Madrid fault zone. A 1.5 near Dyersburg, Tennessee at 6:07 last night. 1.4 near Steele, Missouri at 11:43 last night, and a 1.5 near Ridgely, Tennessee at 12:08 this morning. And then a 2.5 near Pawnee, Oklahoma. And then we've got some more here at Dove Creek, Colorado. Remember, this is where we had that 5.3 on Monday, and it got downgraded to 4.6 or whatever. So we've got a 2.3 at 1:18 this morning, a 1.7 at 7:17 this morning, and a 1.5 at 7:50 this morning. And this one was at a minus 0.1 kilometers depth. So that one was up in the mountain, or the hillside, or wherever it was. Then moving on into Utah, we've got activity over here. We've got 2 at Fillmore, a 1.1 and a 1.4. And then Farron is acting up again. The biggest one in this area is this 2.5 near Salina that came in at 2:05 this afternoon. And then the rest of these are that swarm at Farron. So we have 10 at Farron, and these are like 1.6, 1.1, and this is at a minus 3.4 kilometers depth, so that's way up in the mountain that happened. 1.1, 1.6 at a minus 0.4 kilometers depth, 1.4, 0.9, 2.0, 1.6, 1.1, 1.3. So these were coming in fast. The last one came in at Farron, came in at 10:33 this morning, and the first one was at 7:48 last night. But there were some others that were on the map yesterday too when I did my report. So it's still swarming down there. Then we've got one south of Salt Lake City, a 1.3 near Bluffdale. Then let's see if there's anything in the Yellowstone area. We've got some small ones. We've got some little ones peppered around. We've got a 0.8 near West Yellowstone, Montana. 0.5 near Old Faithful Geyser. Look, it's in the middle of the lake there. 0.8 near Virginia City, Montana. and a 1.8 magnitude quarry blast near Butte, Montana, up here at 12:02 this afternoon. It's like they're blasting on schedule up there. They blast right at noontime almost every day during the week at a -2 kilometers depth. Then up in the Pacific Northwest, up here in the Seattle area, here's the largest one up here, 2.3 near Riverton, Washington at 6:43 this morning, and a 0.1 near Seebeck, Washington at 2:23 this morning. And right down here we've got two, a 0.3 near Morton and a 0.2 near Morton. And that's just north of Mount St. Helens. Mount St. Helens is right down here. And then coming across, this one is new, a 1.3 near Desert Air at 4:16 this afternoon, and a 0.1 near Benton City at 12:53 this afternoon. And then to the west of Salem, Oregon, was a 2.0 near Grand Ronde, Oregon at 7:53 this morning. Then over here, out in the ocean, right at the southern end of this Juan de Fuca plate, was a 2.9. They're calling it near Petrolia, California. That's the city on the coast. That's the reporting station. At 8:21 this morning, 8 kilometers deep. Then down here at the geysers, we've got 43 here today. That's a whole lot. And let's see if any of those are over 2.5 magnitude or higher. Yeah, we got a 3.0 at Cobb. That's considered part of the geysers. It's underneath all that mess. If you go in, here's Cobb, and you just have to look for the biggest one. There it is. There's the 3.0. Now we've got some unusual activity up here in northern Nevada. We've got some big ones, or pretty larger ones, a lot larger ones. These came in. The first one was a 3.7 near Denio Junction at 10:55 this morning at 0.7 kilometers depth. And then just 9 minutes later was a 3.0 near Denio Junction at 11:04 in the morning at 0 kilometers depth. So that's just north of Black Rock Desert. That's pretty high up there, because here's Pyramid Lake. So this is quite a bit further up north. So there's that. Then over here near Ely, Nevada, we've got two. We've got a 1.7 and a 1.8. And then let's look at southern Nevada. got a couple of small ones down here. Then we've got some larger ones down here. 1.2 near Goldfield, 1.6 near Goldfield. Here's some small ones near Hawthorne. Here's a 1.3. And nothing in the Reno area. Carson City's clear. Lake Tahoe is clear. Northern California is clear, it looks like. We already covered the geysers. Let's go down. Here's a 1.0 near Alum Rock and a 1.2 quarry blast near Aromas, California. Aromas right down here. That one happened at 11:03 this morning, 1.7 kilometers deep. Right on the San Andreas Fault. That's not smart. 1.7 near Pinnacles. Here's a 2.0 near Taft. And 1.4 near Taft, right on the San Andreas Fault line. Then let's cover Southern California, then we'll come back up on the east side. We've got 20 on the map today. Let's see if we have any of these 2.5 magnitude and higher. No, they're small, but small ones count, because small ones can lead to larger ones, as we've seen. So we've got 20 here. Here's a quarry blast of 1.3 magnitude near Big Bear City at 5:10 yesterday afternoon at a minus 1.4 kilometers depth. Right up there. Look, and there's another blast right next to it. And then a 1.2 at 10:50 this morning. So whatever they blasted yesterday, they finished it up today at minus 1.4 kilometers depth. Yep, same depth, same place. So, got their blasting done to make some more earthquakes. Most of these are in the ones in under range, it looks like. Yep. So not too many down here. Here's a little cluster of 4 near Ocotillo Wells. Here's the Cahuilla area. Wait, is that Cahuilla? No, Borrega Springs. Here's Cahuilla. Cahuilla is eerily quiet. 3 here today. So I don't know what's going on there. So, coming on up, here's a 1.2 at Bodfish. Here's a, we've got 2 at Little Lake and 2 at Coso Junction. So they're pretty much the same place. So 0.5, 1.1, 1.3, and there's a 1.3 and a minus 0.2. So that was a microquake there. Coming on up, here we are moving into the Long Valley and Mammoth Lakes area. We've got 8 here today. 0.4, 0.3, 0.4, 1.2, 0.8, 0.6, 0.7, and 0.5. So that's pretty active. They're small. Nothing at Mono Lake. I think that's a wrap. So let's back out, zoom out, and see if anything else of note came in while we were looking at all of this. 3.6 near Kodiak, we saw that at 4:09. We saw the Harara, Japan. We saw the Cold Bay. We saw Cobb, Bear Creek, Willow. We got all of those. So we're going to wrap it up for today. I hope everyone has a wonderful weekend. Remember that this is the Daylight Savings Time weekend. To go on Daylight Savings Time. For those of us in the United States, we get to move our clocks forward tomorrow night. Saturday night. Not tonight, but tomorrow night. So, I know a lot of countries do observe Daylight Savings Time at different, it's all different. So you just have to do a Google search and see who's going on it. So I love you guys. Time is short. It's shorter than we think, especially with 8 billion parts per billion of methane stored in the ice up there in the Yamal Peninsula. Blows my mind. It's time to get right with God and Jesus. If you haven't done so, that's the fastest way I know to get that tractor beam to heaven. Because I'm telling you, I don't want to be around for when Satan is ruling completely and the battle is waging completely. I don't want to be around for that. So until next time, God bless everyone. Go in peace, and I'll talk to you soon. Goodbye.